Hi viewers, welcome to another tutorial of the 2024 ECZ GCE exam. In today's video tutorial, our main focus is on question number 6 under the topic of trig identities coming from paper 1 additional mathematics. So this is the ECZ examination for General Certificate of Education ordinary level. So this is the paper. The paper. It is paper 1 additional mathematics. So now let's try to check where the question is. Let's try to check where question number 6 is. So this is question number 6 that we are talking about. This is question number 6. So question number 6 says prove the identity. And then we have sine squared theta minus open brackets 1 plus tan squared theta close brackets cos squared theta, and then over sine theta cos theta, and then that is equivalent to negative cos theta. So this is the question that we are going to be considering today in today's video tutorial. So this is the question that we shall be considering. So you have to watch through the video tutorial up to the end so that you know the concepts behind this question. So as you are getting into the solving, don't forget to subscribe, to like, to share, and to comment. So when you subscribe, you will be updated with each and every video tutorial which is uploaded on this YouTube channel. And then when you share, others can enjoy the tutorials of additional mathematics. So when you comment, we shall be proud to hear your views. And also don't forget to like. Let's now try to get into the solving. Okay, so this is the question that we're interested in today in today's video tutorial. This is the question which says prove the identity, and then that is the question below there. So it is sine squared theta minus open brackets 1 plus tan squared theta close brackets cos squared theta, and then over sine theta cos theta, and then that is equivalent to negative cos. So in this video tutorial, we are going to show you different concepts which can help you get to know this type of question. So let's now try to start. Let's start the question, the solving. So what you should know and what you should keep in mind is that on the left, those which are on the left, when you try to simplify it, it should be equivalent to negative cos theta. So when you simplify what is on the left, what you should get is negative cos theta. So now let's try to simplify what is on the left so that it gives us negative cos theta. So what you should keep in mind is that sec squared theta is equal to 1 plus tan squared theta. So sec squared theta is equal to 1 plus tan squared theta. That is what you should get. So now those which are in the brackets, which are 1 plus tan squared theta, you can replace it with sec squared theta. So that is what we're going to do. So it will be sine squared theta minus sec squared theta, and then that cos squared theta will maintain like that, and then we're going to say over sine theta cos theta, like that, and then that is equivalent to negative cos theta. So now our next step is to identify that that one which is sec square, which is sec squared theta. So sec theta is equal to 1 over cos theta. That is what you should keep in mind. So sec theta is equal to 1 over cos theta. Now if it is squared, what should you do? If it is squared, so in that case it is sec squared theta. It means that even that side it is also squared. So in that case it will be sine squared theta minus open brackets 1 over cos squared theta, and then we also have cos squared theta outside the brackets, and then over sine theta cos theta, like that. And then what you should keep in mind is that when you divide cos squared theta divide by cos squared theta, it will give you the value of 1. So those two, we are going to simply cancel them out. So it will be something like that. So it will be sine squared theta minus 1, and then it will be sine squared theta minus 1, and then down we have sine theta over sine theta cos theta. So now let's try to identify another identity. So sine squared theta plus cos squared theta is equal to 1. So sine squared theta plus cos squared theta is equal to 1. So now what we're going to do is that we're going to make sine squared theta the subject in this video tutorial. We're going to make sine squared theta the subject. So it will be sine squared theta is equal to 1 minus cos squared theta. When cos goes to the right hand side, it will be a minus, and then it will be 1 minus cos squared theta. So where there is sine squared theta, you're going to replace it with 1 minus cos squared theta. So it will be 1 minus cos squared theta minus 1. So and then down we have sine theta cos theta, and then we have the like terms. Those like terms are 1 and negative 1. So when you try to simplify them, it will be 1 minus 1, and then it will give you the value of 0. So we are simply going to cancel them out, and then we are simply going to remain with a negative cos squared theta. So it will be negative cos squared theta over sine theta cos theta, like that. So now we have cos squared theta up there. So we have cos squared theta. So cos squared theta, it means that you have to you have two cos thetas. You're going to get rid of 1. So 1 will be divided with the one which is down, and then you are simply going to remain with only 1 at the top. So it will simply be negative cos theta, and then so it will simply be negative cos theta over sine theta, and then that is equivalent to negative cos theta according to the question. So now what you should keep in mind is that cot is equivalent to cot is equal to cos theta over sine theta. That is what you should keep in mind. So cot theta is equal to cos theta over sine theta. So now you're going to say negative cot. So now you're going to say negative cot theta. Negative cot theta is equivalent to negative cos theta. Now you're going to ask yourself, is negative cot theta equivalent to negative cos? So the answer is no. They want to know how you're going to prove it. So in this case, what you have to write is that hence this identity cannot be proven. Hence this identity cannot be proven. So when you look at that carefully, negative cot theta is not equivalent to negative cos theta. So you can say that hence this identity cannot be proven. So now, how? You're going to say how. How can it be proven? This is an exam question. This is an exam question. They can't make mistakes or what. So you have so what you should keep in mind is that if this question wasn't if this question was a mistake, that negative cos theta was supposed to be negative cot theta, but provided that this question wasn't a mistake, this is what you should write. It is supposed to be hence this identity cannot be proven. So now this was more like a question which can waste your time when you are in an exam room. When you are in an exam room, this can cost you your time, whereby you can spend a lot of time trying to figure out why is it giving you negative cot theta while theirs is negative cos theta. So in an exam room, during the time of the exam, especially during additional mathematics, you have to make use of your time. You have to make use of your time. Don't spend much time on one question. So that is what you should keep in mind. So you can find that you waste your entire 1 hour trying to figure out the answer for this question, whereby this is just 4 marks, and then you leave big marks, like you lose 20 marks just because of 4 marks. So when you are writing an exam, try to be smart. So now let's try to figure it out. Why can't this let's try to figure it out. Can this question be proven? Have we made a mistake somewhere, or it's just the way it is? It can't be proven. Now let's try to figure it out. Can this actually be proven or not? So proving that this identity cannot be proven. So let's try to get another example, which is from somewhere else. So tan theta is equivalent to sine theta over cos theta. So tan theta is equivalent to sine theta over cos theta. Now what we're going to do is that we're going to replace where there is theta with one angle. So we're going to get one angle. In this case, we're going to get 45 degrees. So we're going to say tan 45 degrees is equivalent to sine 45 degrees over cos 45 degrees. So now what the value you get on the left hand side should be equivalent to the value that you get on the right hand side. So when you use your calculator, on the left hand side it will give you the value of 1, and then on the right hand side, when you use your calculator, it will give you the value of 1. So this has been proven. So hence this has been proven. Now let's get to the question. Let's try to get to the question. Let's try to prove if this can actually be proven or not. So we're going to get one angle. We are simply going to do the same to this. So we are simply going to do the same to this question. We are going to replace theta with one angle on both sides So it will be something like that. So we are going to replace. So you're going to replace, in this video tutorial, we chose to replace theta with 45 degrees. So it will be sine 45 degrees squared, open bracket, sine 45 degrees, close bracket, squared, minus 1, minus, open brackets, 1 plus, open brackets, tan 45 degrees, close bracket, squared, and then cos 45 degrees. So sine 45 degrees cos 45 degrees, and then on the the value you get on the left hand side should be equivalent to the value that you get on the right hand side. So this should be equivalent to negative cos 45 degrees. So on the left hand side, the value that you're going to get is negative 1. When you use a calculator or whichever way, the value that you are going to get on the left hand side is negative 1. What about on the right hand side? On the right hand side, it will be negative 0.707106781. Now, is negative 1 equivalent to that value which is on the right hand side? No, this is not equivalent. So this is how this is now we can now be 100% sure that this identity cannot be proven. So that is what you should keep in mind. So hence this identity cannot be proven. This is where you're supposed to end when you are attempting this question. So this is how it should be. Thank you for watching. See you to another video tutorial. I hope you haven't forgotten to click the like, share, and to also subscribe to this YouTube channel. So thank you for watching. See you to another video tutorial.